Now, in this question, find k pairs with the smallest sums. What do you have to find? You have to find the smallest sums, and this is where the hint lies. When it says smallest sums, you would first think that you need to use a minimum heap. You need to use a heap, and in Python, it's automatically a minimum heap. So, how do you start this question? First, you start with checking that what if your either of your nums of 1 or your nums of 2 is empty, or your k is less than or equal to 0, which means you don't need to proceed anything. In this question specifically, you have to make k number of pairs. So in this example, you need to make 3 pairs, right? As I said, you start with a heap, with an empty heap. You initialize an empty heap, and then you start with a for loop. So what will you do is you will populate the heap. So you say for I in range minimum of either k or length of nums minus 1. So it will go until it either reaches k value or the end of your nums 1. And the reason why I do this is because even if there are million values in your nums 1 array, but you only need to make k pairs, which means you only need to use the first k number of values. For example, if this is 3 and this is a million, you don't need to run this for loop a million times because you only need k pair of values. And you know this is also sorted. So there's no use of iterating the loop a million times. You can just exit it quickly. So for I in range, whenever it hits the minimum, so either k or length of nums 1, you push into the heap. Now what do you push in the heap? You push the sum of nums of I, where your ith pointer is in your nums 1 array, and nums of 2 you set it to 0, because you know that your 0th value, 0th index will always be the minimum. So 0 of whatever you're picking from this will always make the minimum. So if you advance your pointer in nums2 as well, your value will keep getting bigger. So if you fix your pointer in one of the arrays, then you can get minimum values. And also make sure you remember that nums1 0th index and nums2 0th index will always be the minimum value, the first minimum value, because this is the lowest you can create. And then ith is the index into the nums1, and 0 is your index into nums2. In this case, it's set to 0 because we are only considering the 0th index in nums2. Now result, you set it to empty array. You start a while loop until your heap is empty and your length of your result is less than k, because you need to hit k values, right? And then you pop from this heap. You pop 3 values, so your sum, your I, and your j. In this case, you don't really need to consider this h. Instead, you just look at I and j. Now you append to the result your nums1 ith value and nums2 jth value. You don't do any checks to begin with, because your first value that will be popped will always be the minimum value, because the first value that you will pop will always be nums of 0 and nums of 2 0, nums2 of 0. So the first value of both the arrays. And then you do a check, which means what if you go into the next column? So what if you advance the jth pointer, and then this time you fix the ith pointer? So if j plus 1 is less than nums of 2, the reason why you do this check is because you basically set a guard that if you have advanced the jth pointer until the very end, which means you have exhausted all the values, like this whole row is exhausted. So if you have, for example, matched 2 with 1, 4 with 1, and 6 with 1, you have made all possible combinations using nums of 2, so which means you have advanced this row. Now you need to consider 2 with 7, 4 with 7, and 6 with 7. So until you have reached the end of this jth value, you will push into the heap your nums1 of I, which is set, nums2 of j plus 1, and again which is the ith pointer, and your j plus 1. and again it will go through this while loop. At the end, you just return your result.